Okay guys, here we are at Unit 8, Basic Joints. So I'm sure we've all gone over this at least a little bit, like our 2A classes and 2B classes, but we're going to go over it again. So this is basically just joint fit-ups, different joint types. Okay, so from the previous unit, Unit 7, I remember material profiles, material types. So we should know what the difference is between that bar and structural stock. Remember that bar stock is more the light duty fabrication, the tubing versus the structural stock would be like your pipe, right, compared to the tubing, or your plate versus sheet metal, okay? And so what are the primary differences between pipe and tubing? Remember on pipe, again, that's structural. It's designed, it's engineered based around the sizing for predetermined pressures for gases and liquids, versus tubing is meant more for fabrication, and in some circumstances, like we talked about in the previous video, can also be used in structural environments. Okay, so there's nothing set in stone as far as that goes. We should know at what material thickness we go from sheet to plate. A little typo there. So what is that threshold? Remember, 3/16 is that considered sheet or plate? Okay, it's 3/16 is plate. All right, 3/16 and above is plate. So less than that would be considered sheet. And then what measurement always comes last when dimensioning material? Okay, so if we've got square tubing that is 1/8 inch wall, it would be, if it was if it's square tubing, right, not rectangle, square, and it was 2 inches, it would be 2 inches, meaning the width and the height are 2 inches, by the wall thickness, 1/8 inch, by how long? Okay, so length is always that last dimension. Okay, so for this unit, we'll be going over the 5 basic joint designs, discuss the types of welds applied to a given joint design, and interpret joint designs from shop drawings, and then interpret a couple welding and cutting processes from written abbreviations. So like the acronyms like GMAW, FCAW, okay, those are the abbreviations they're talking about, and good Lord, there's a ton of them. There are so many. So we'll get there towards the end of this PowerPoint, but man, there's a lot. Okay. So the basic welding joints, there's 5 basic designs. You've got your butt joint here, your corner joint, T-joint, lap joint, and edge joint. Okay, so those are the 5 basic welding joints. That covers all your bases. And you got to remember to differentiate between this is the joint type and this is the weld symbol. Okay, so joint fit up and weld symbol. Depending on the prep, you might have a different weld. But this is always going to be a butt joint. All right, this is always going to be a corner joint. No matter what kind of weld goes in there, this is a corner joint. So just learn to kind of differentiate those. So first one up is going to be the butt joint. This is where both members are butting members, so they're running into each other. All right, they're both butting. The basic geometry is 2 members aligned edge to edge, with or without root opening. So whether there's a small gap here or not, it's still considered a butt joint. The 2 facing edges of members left with mill or square groove. So if there's no prep, okay, no beveling, no cutting, if it's just the 2 ends, it's called a square groove butt joint. Okay, so just like the shape, if you open that up, would be a square. So it's square groove. So your corner joint, so whether or not these are running into each other, right? So you can see right now, if this vertical piece kept going, it would not be running into it, okay? So whether this is butting or not, it is considered a corner joint. So this is a open corner joint. You have half enclosed corner joints. And here they are. So this would be a closed one where right now we are a butting member. And then B, we're still a butting member. It's still running into it. And then C, we are no longer. Okay. So this would be a closed, a half, and an open. All right. And you can see right here, you're going to have a fillet weld. And then this, if you weld that on this side, what would that be? That would be a square butt groove. Okay, so same joint, different welds. All right, here we've got our generic T-joint. So contains both, again, budding, non-budding member. This is budding into this one, but this one is not. The edge of the budding member is budded into the surface, okay, of the non-budding member. So the budding member is the vertical, the non-budding member is the horizontal. Without any joint preparation, it's always going to be a fillet weld. All right, but with certain joint preparation, you could make this like if you did like a bevel on this plate, this would be considered a groove weld. Okay, but fillet weld is the most common type of weld for economic reasons, right? Rarely would you ever need to bevel a T-joint to get better penetration, but there are circumstances where that happens. Okay, so lap joint, uh, both members and again non-butting members, so they are overlapped each other. Okay, uh, the predominant type of weld again is going to be a fillet weld. Very rarely are you going to see beveling of any kind before doing a lap weld. This is more common in sheet metal and things like that, but it can definitely be common in structural with gusset and reinforcement webs and stuff going on I-beams. But a lap joint is just two uh, uh, on different planes, but surfaces touching pieces of metal with overlap on them. So an edge joint, these are two non-butting members. Okay, so they are just surface to surface with their edges being parallel. Okay, so anything beyond a 30-degree separation, meaning right now they're parallel. If this right side plate came off at a 30-degree angle, that would make it, or I'm sorry, if it, more than 30 degrees, so 31. If this came off at a 31-degree angle, it would become a skewed corner joint. Okay, so you can have skewed joints depending on the misalignment of them, and the threshold for edge joint is 30 degrees. I think for a butt joint, it's anything outside of 180. So anything outside of both those plates in a butt joint being perfectly parallel on the same plane would be considered a skewed butt joint. Now we have flange joints. So flange joints are kind of in a league of their own. So this is less common. You see this more in like sheet metal, so like a rolled ducting or paneling. You get a lot of sheet metal that gets rolled like this because it stiffens it, and so all of these would be considered flanged welds. Okay, all right, some form of a flange, like this would be a double flange weld, single flange, single flange, single flange, single flange, single flange, double flange, single flange, but they're all flanged welds on flange joints. Okay, butt joint, corner joint, T-joint, lap joints, and edge joints, and that would be a flanged groove weld. So more skewed joints. Yeah, skewed butt joint has an angle of something other than 180. So other than them being perfectly lined up, it is considered a skewed butt joint. For corner joints or T-joints, if it has an angle that is not 90, okay, so if it is not perpendicular, if it's not 90, it's considered skewed, but the type of weld applied would be the same if it was for a non-skewed joint. Okay, so it would still be considered a fillet weld. Okay, so the components within the fit up of a joint will vary depending on the type of preparation. So right here with no preparation, your root faces, that's going to be where the material intersects at the center line. The joint root is where they interface at the intersect at the face, so at the edge of the material, and then the groove face. All right, that's where the material will be removed or deposited. So for a V groove, you get a little more detailed. Okay, so the root opening is going to be the gap between the plate at its closest point. All right, if this was a square groove, then it would be, 3/32 all the way up, but we have a V groove, so we have this bevel here. Okay, so the root opening is going to be right here. The flat spots are called the root face. The beveled section is the groove faces, and then you have your bevel and groove angle, or your included angle. Okay, and the bevel angle is the angle of this single bevel. So what you set that torch at when you cut it on the track cutter, um, like a lot of you guys in the structural class, you're probably doing like 45-degree groove weld. So you're going to cut one side at that 22.5 and the other side at 22.5, and that gives you that 45-degree included angle. Okay, so bevel angle is the angle of one side. The included angle is the whole opening. Okay, so these abbreviations, there's a ton of them. All right, and this is just again like the acronyms you would have for like GMAW, gas metal arc welding. So there's a ton. So we're not going to sit here and just list them all. Okay, but we'll go over some of the kind of more common ones. And there's a lot more to this than you probably realize. So we have these, they're called allied processes. So thermal gouging, thermal cutting, thermal spraying. Okay, they use similar equipment, they're similar processes, but they're not the same, right? Carbon arc gouging would be thermal gouging. Okay, oxygen gouging or plasma arc gouging uh, versus thermal cutting, right? Cutting is different than gouging, but you still have oxy-fuel cutting. You could carbon arc cut and you could plasma cut. So that's why they call them allied processes. They're similar enough. They're like cousins. And then thermal spraying. So this would be like if you ever seen like a factory where they're spraying zinc coating, all right, things like that. That would be thermal spraying. And then thermal cutting, lots of cutting processes. All right, so over here at the oxygen cutting, you've got flex cutting, oxy-fuel gas cutting, right, your OFC, what we've all been doing, oxyacetylene cutting, oxyhydrogen, oxynatural, the different fuel sources. And then you have your high energy beam cutting. So this is laser cutting. So electron beam cutting and laser beam cutting. And then you have your arc cutting, which is where you would have your air carbon arc cutting and your plasma arc cutting. Okay, so these are all different thermal processes for cutting, gouging, and spraying. And there's 30 of these. And then I think 90 total of all the welding and fusing acronyms, abbreviations as well. So there's just a ton. And then you also have different methods, right? Adaptive control, automatic, manual, mechanized, robotic, and semi-automatic. So mechanized would be like, think about your track cutter. Okay, it's a machine that you kind of turn on, but you got to be present. You got to be there to turn it off when it's done. But it's doing like basically the whole cut for you. You have the manual process, which would be like you oxy-fuel cutting or plasma arc cutting or SMAW welding. Okay, you're in control of everything. It's you. You're using the tool and you have full control of it. Versus semi-automatic, which would be like a GMAW wire-fed process where you're holding the tool, but the tool is still doing some of the work. Okay, so it's an assist. And then robotic. So robotic, different than mechanized, because robotic is you're programming that robot, telling it to go, and then you're not doing anything until you tell it to stop. So it's mostly prep through the programming and then running on its own. Okay, so that's the end of this unit. So we'll see you in unit 9, right? 9. Unit 9, almost done.